Hi everyone, welcome back to workshop, and it's repair slash restoration time again, and this time I've got a Farnell L30/1 bench power supply. Picked this one up pretty cheap. It's ex-MOD, that's Ministry of Defence, and this single channel power supply is going to complement quite well my LT30/2 dual channel power supply, the bigger brother basically of this one here. So this one's in probably a little bit of a state, as you can see. Yeah, it's got a switch that's hanging off the front, and it does appear to be missing the Farnell sort of clip-on label that goes across here. The photograph that I was given when I first saw the unit did actually have it in place, so I have actually contacted the seller, and they have got it, and they're posting it off to me. It must have fell off when they were packing it, because it just sort of clips on. But anyway, yeah, this is it here. No plug on it, as you can see. A nice little analog power supply. There's two versions of this one, if I remember rightly. There's an op-amp based one and a transistor based one. Without opening it up, who knows what version I've got here, and who knows whether it actually works. So the intentions with this power supply is basically to clean it up, get rid of all these labels, put everything back as it should be, get it up and working, and stick it on the workbench. So the first thing I'm going to do is take the cover off, and let's have a look inside. Missing some screws on the side as well, but somebody's been in it at some point and just shoved the cover on any old way, and like I said, because it's missing the carrying handle on the top, but I usually take them off anyway so that I can stack other gear on top. So here we go, let's have a look inside. Let's go an earth wire there. Let's turn it round, let's have a look. Well, it doesn't look like it's in bad shape internally anyway. Got a transformer at the bottom there, big electrolytic capacitor on the back panel. You've got a couple of transistors in the back, they'll be the main power transistors. And you've got the actual control board here mounted on the back of the analog meter there, which doesn't look as if it's in too bad a condition. All the wiring down here looks like it's in place. Nothing looks burnt out or hanging off or anything like that, so hopefully we should manage to get this thing up and running. One thing I did notice, we've got a transistor mounted on the back panel there. I wonder if that's driving the main transistor on the back, the T05 package transistor on the back. So I do actually have a couple of schematics here for this sort of range of Farnell power supplies here. Maybe not the exact one for this one here. I've got an L30/1 schematic here. This is the non-op-amp version, the transistor version there. So now that I know I've got the op-amp version, this one's really of no use. And the only other one I've got is the schematic for my other bench, the dual mode one, and this is for the L30/2 or LT30/2, the op-amp version here. So I think we're just seeing sort of one channel here, so hopefully this is more or less what we've got here. Because if I remember rightly, in the LT30/2 that I've got up in the workbench, the two channels are actually more or less completely independent, and the schematic is just showing you one channel here. So hopefully this is the same as this power supply that I've got here. If I need it, who knows, the power supply might work out the box. We'll just have to power it up and take a look. So actually looking quite good that I've got the right schematic actually, because we've got 4 potentiometers on the top here. P1, P2, P3 and P4 as they're marked there, and we do actually have a P1, a P2, a P3 and a P4 marked on the schematic, and the idents for the pots seem to match up as well with the idents on the PCB. The other pots that we've got there, that'll be the front panel controls, the coarse adjust for the voltage and the fine adjust and the current set over here. So looking like we've got the right schematic. And one other thing, we do actually have a couple of fuses on the underside there, an input fuse and an output fuse. And we've got a fuse on the PCB there as well, and that's not blown, so everything's looking good. I think I'll just go and whack in some power and see if it's working. So here in the UK, when we're faced with powering up a device that isn't supplied with a plug and the tails are just hanging off there, what I like to do is use my Quicktest. I'll put a link in the description down below to these, because they're really handy. Basically, you've got a 13 amp plug here coming into here, and you can basically just open up these here, put in your tail, and that's it. And you do that for your live, neutral and your earth. It's completely isolated when the top's open, because you can see the knife edges there and the fuse. They don't apply power to the output clamps there until you actually close the lid there. So with it open, you've got lots of isolation, and it's really safe to use. Fused, got a neon, can't go wrong. But I hear you screaming, it's XMOD, don't put 240 volts in it until you know the supply that's meant to be set to. Well, yeah, of course. And there's no identification on it at all, whether it's 240 or 110. I don't even know if they sold these at 110, but we've got a nice transformer down here. So I think we'll take a look at the primary side windings there. It's we have got some identification on the side of the transformer, so I should be able to work out whether it's set to 110/240. So let's have a look. So if you look closely just here, you'll see the word 130. Well, actually just out of sight next to that is 4 other numbers, a 0, 110, a 0, 110 and the 130 at the end there. And we've got the wires going in here and a link or two or whatever down on the interface to the transformer. So let me draw it out and let me show you what we've got there. So here we are looking at a schematic. We've got a 0, 110, a 0, a 110 and a 130 at the end there. And it's drawn here with the 2 primary windings in series, so that's going to be for your 220/240. We've got a link on the piece down on the transformer there, a little pink wire. That's this one here, linking the 2 ends of the primary windings together, so that we've got our AC coming in right across here and here. So we're definitely set for 240. The extra winding at the end is just so that you can select between 220 and 240, and at the moment it's set, the wire is interfaced to the 130 end, therefore we're configured for 240. So I think we're good to go with 240 volts. And one other little test before I actually hook it up is just to make sure that we've got an intact primary winding on the transformer. So across the brown and blue, the live and neutral wires, we've got 26.2 ohms, so that's looking good. And we'll also check that we don't have a short between earth and the live and neutral, which we don't. So it looks like the primary side of the transformer is intact. So let's go put power in. So I'll just tidy up these wires on the ends here and put them into the Quicktest block. Live neutral, the brown one's a bit short but should be okay. These clamps are really good because they're really strong, and you can't really pull out the wire unless you really give it a heavy tug, even for these small conductors here, so quite good. There we go. And I'll plug in power for the Quicktest. We've got a neon now, so let's put power in, see what happens. Okay, we've got power on. Well, we've got something, and I'm adjusting the coarse front panel control there, which looks like it's varying, as does the fine control. Okay, let's get a multimeter in the output and see what it's doing. Okay, here we go. Right, we've got the switch at the right hand side there. The LED is the output limit, but this is actually the on-off switch that controls the actual output. Meter's always going to read what the potentiometers are set to in terms of output, but you won't actually switch on the output until you hit the switch down. So there we go, and we should have something on the meter. 12.7 volts. So let me just screw that up to say 15. That's just bang on 15 there, and we're not too bad on the meter there, so it looks like it's working. I'll go up to oh, potentiometer's a little bit dirty around about 25 volt mark, certainly, and about 30 volts there. Yep. And down at the other end, let's see if we can dial up 1 volt. That's about 1 volt. So yeah, a little bit out. Let's see what the zero on the meter's like. So I'll just switch off power. And maybe reading a little bit low, but not too bad. 5 volts maybe. So it looks like it could do with a little tweak. So the next thing to do is give it a load and see what it does. So off camera I've got my DC electronic load hooked up. Got it currently set to 0.5 amp. So I'm on 5 volts there. So let's just turn on the electronic load. And we're at current limit already, so obviously that's this control here. I'll wind it right up so that we've got no current limit in operation. And we're about 0.4997 amps so on the DC electronic load. So I'll switch to amps on here, and we've got just under the 0.5 amp there on the 1 amp scale there. Oh, there we go. Well, we have got a problem. I don't know what that was caused by. You saw that jump up to 0.6. Well, it's definitely nice and stable at 0.5 amp on the DC electronic load, so something's not right. Definitely jumped up to 0.6 there. Right, I've just reset the DC electronic load now to 1 amp. So let me just turn it on and hit the power. And we're still on there on amps, so we've got 1 amp full scale. I'll just take it down to 0.75 on the electronic load. So yeah, that's following nicely. Down a bit yet off camera. Let's go really low. Let's go down to 0.1. And yet we're halfway between 0 and 0.2, so that's your 0.1. So far so good. The only thing I've noticed so far was when the meter just suddenly jumped up to 0.6 and back down again. So we're on the 5 volt scale there, 5 volt output there. So I'm also going to turn off the electronic load and let's go for broke. Let's go right up to 30 volts output there. The DC electronic load showing 29.974, so that's good. So let's turn that off there. Turn on, we'll go for 0.5 amp. And 30 volts. Oh, we're off. There we go. 0.5 amp exactly. Let's see, and it's so we're 30 volts. 0.5 amp. See if I can make that jump around again, which was a little bit weird. I can actually smell the power supply now, so something's getting hot somewhere, but it's to be expected at the load I'm giving it. Maybe I don't think it was a sticking needle, because it made a positive jump up to 0.6 and then a positive jump back down again, if you know what I mean. So let's go for 1 amp now. And that's 1 amp, that's 30 volts, 1 amp, and the DC electronic load is still showing 29.97, so that's good. So we're full power output. I can turn off the output there. And the current, let's see, I wonder if it had gone into current limit mode. I've got dodgy. I think that's maybe why the meter jumped. I think this pot's a little bit dodgy for the current limit, so maybe it did something there. Certainly at the top end it's a little bit scratchy. It's not too bad further down. So now I'm limiting the current now on the power supply. Yeah, I definitely dodgy round about there. That's off, and the slightest tweak brings it back up. So we've got a pot that we need to clean up there for sure. So let me just go to 1/2 amp there, and the DC electronic load is showing 1/2 amp as well. Really dodgy round about the 0.2. Yeah, so that pot definitely needs looked at. So let's turn off the DC electronic load and go back to the voltage scale, and let's see how the other pots are doing. So I'll just adjust this one here. Just winding it up slowly back and forward to see if there's any jumping on the meter. Little bit at the top end when my full scale deflection on the pot, you can see it sort of wavering. There we go, wavering back and forward there. So that pot's probably needing a bit of a clean as well, maybe replacement. So now I'll try the fine one. So I'll just go to center scale there. This one will be less noticeable because you've got less deflection on the voltmeter. Yeah, that one looks okay actually. Yep, so we've got a couple of pots definitely that need cleaned up, and probably the switches need a clean up as well. So like I said earlier, you could smell the power supply when I was running at load, and this resistor here is really quite warm here. That'll be the shunt resistor for the ammeter. So it is quite warm. Obviously I was running it with an amp basically going through it, so yeah, that's not too bad. Everything else seems okay. Transistors are basically stone cold. The heatsink in the back, you can feel a tiny little bit of heat on the actual, there's 2 transistors behind this heatsink here, and you can feel them a little bit. They're just very slightly warm, but nothing much at all. This transistor in the back there is stone cold basically. Now, like I said, I think that's driving the 2 in the back there. So the only thing that's generating any sort of heat is that shunt resistor there. So next thing to do, I think I'll strip down the front panel and get access to the pots and remove them, and let's take a look at see what we can do with them. Okay, a very quick run through the schematic here. So over here we've got the mains transformer, as I'd said earlier. We've got 2 secondary windings on the transformer. One is providing power, DC power, via this bridge rectifier here for the main output transistors here. You can see you've got 4 2N3055s, and the drive transistor there for those transistors is that 2N5294. That's that TO220 package transistor that was mounted inside the case. The other secondary winding powers the control circuit and all the op amps and transistors etc. on that. So you've got a bridge rectifier on the circuit board itself providing power here, and then there's a semi-regulated DC power supply. Basically you've got this R1, this 470 ohm 6-watt resistor. That was that resistor I was pointing out earlier on that I thought was a shunt resistor. No, it's not the shunt resistor. The shunt resistor is way over here. This one here is part of the semi-regulated DC supply. You've got 2 Zener diodes there, a 15 volt and a 5.1, and they're in series in order to provide a split rail virtual 0 volts there on the 5.1 level there. So the bridge rectifier there's your negative side along there, and then your positive side along here. So at 5.1 volts with reference to the negative on the bridge rectifier is the 0 volts for the circuit. The negative 5.1, as we'll call it now, is basically providing a negative supply for the op amps in order that the whole circuit can work down at 0 volts. So you've got here's that R1 there. So on the other side of this here you've got your 15 volt supply, and this section here with this 1N823, that's a 6 volt temperature compensated Zener diode, and that's providing a reference voltage for the external pots for the voltage adjust. So you can see the two pots there coming down onto the board, where you've got some calibration control over those pots. And then you've got the output from the pots coming down. They're summed together because one's a fine and one's a coarse. They're summed together onto this point here, and that comes into this op amp here, which is basically just buffering it down onto these two op amps here. This op amp here is for your constant voltage control. It's a classic circuit. You've got a diode in the output there, and on the other op amp there, which is connected via the shunt resistor here. Follow that line down there, and there it is there, and you've got the current limit control there coming into the same op amp there, and you've got another diode on the output of that one there. And basically it's like an OR circuit with the two op amps, and that controls the main output transistors there. So you've got a constant voltage control and you've got a current limit control. And then the output from the transistors, basically this is it down here through the shunt resistor, as I said earlier. Then your on off switch on the front panel, and then direct, that's your output there. Now of course you also have the meter on the front panel there, which is selectable in either voltage or current modes there, so that'll tap into the appropriate part of the circuit there to pick up the voltage or the current accordingly. You also have an I constant output there. That's the blue terminal, the blue banana jack on the front panel, and that's basically a constant current output, and not a lot of people use that one or even know what it's for, because the main current control that you see here is not a constant current, it's a current limit, or what they would call a current ceiling control. It's not constant current. If you want the constant current, you would use this blue terminal down here. Then you've got some protection on the main output there. And then down over at this side here, you've got this 4863 volt electrolytic. That's your main bulk capacitor on the output that drives the main transistors there. Right, let's see if we can access these potentiometers. So there's a couple of screws on the underside here that I think I'll just take off the front panel. I'll let it fall to the front, so I'll just remove them now. And carefully just open it, just sort of flaps down to the front, and there we go. Nice access to the PCB and the potentiometers. So looking at the actual PCB, as I mentioned earlier, you've got the bridge rectifier there, you've got a fuse, you've got the adjustment potentiometers there, obviously you've got the couple of plugs there to take the wiring off the PCB, and you've also got these two nuts here. That's the back of the actual meter on the front itself, the analog meter. So it serves two purposes. That's your actual physical mounting point for the PCB, but it's also the electrical connections for the actual meter itself. And then there's a hole in the PCB here with meter 0 next to it. That's to give access in order to null out the meter. So I will need to do that because it is slightly off. And that's the PCB. And down onto the main front panel, you've got the 3 spectral reliance potentiometers there. You've got the front panel switches. The mains one, you can see it's shrouded in a little bit of looks like heat shrink sleeving, actually, just to make it a little bit safer. And you've actually got a PCB for the banana sockets to mount to there, with a couple of components on it, protection diode, etc., as I'd mentioned earlier. So let's remove the pots. I'll do them one at a time and give them a little bit of a clean up. I've got some deoxit. Hopefully I can spray a little bit of deoxit inside them and give them a good going over and see if I can get them less scratchy. So the first thing I'm going to do is actually make a note of the wiring. Well, I won't make a note, I'll take a photograph of the actual wiring of the potentiometers themselves before I actually desolder them if I need to. I'm not sure if the wires are long enough that I can actually pull the potentiometer out and work in it whilst leaving it connected, but we'll try our best. Right, I took the caps off and loosened the nuts off camera because boy were they tight. I don't think they've ever been off since the day this thing was put together back in the day. And there we go, with the first potentiometer off. Spring washer on the inside and the nut on the outside, and then there's another nut down on the shaft itself just to space it out a bit. Right, with the first pot removed, well, the wiring's still in place, and just rotating it by hand. Wow, it's grindy at both ends more than anything itself, but right, with the first pot removed, I've not bothered desoldering yet. I don't think I will, because the wiring has been put on properly. It's actually been looped through the hole in the actual terminal itself in the pot, and then twisted and then soldered in place, so it's quite messy really just to take it off. So I'll probably just working it as it sits there. So let me just take this nut off, get it out of the way. There we go, and it's, yeah, and it's really quite grindy. So let's see if I can find an aperture or a hole in it somewhere that I can get the deoxit inside. Well, unfortunately it looks like I'm a little bit out of luck. These are actually sealed pots. You can see the gunk there where the two halves have sort of been glued together, and there's no holes in it at all. I mean, they're just 5k pots as signified by the MW.E 502, the 502 being 5000 ohms, so that's 5k, and the schematic backs that up, so I think they're all the same. Yes, 3 502s. So I think the only chance I've got is maybe I could get some deoxit down here, down behind the circlip, and hopefully then maybe it seeps down inside. So I think I'll give that a go to start with, because I'm just not seeing any holes anywhere else. Even down the sides of the terminals there, it looks like they're sealed. It doesn't look like there's much at all, and yeah, they're just glued together. So, you know, normally there might be spring clips holding the two halves together in some pots, and you can actually get inside them. You can open them up and get right inside them, but I think I'm out of luck with these ones here. But this is definitely a scratchy one. It's a good candidate to test the deoxit, so we'll give that a bash right now. Right, got a cloth there just to stop it going all over the PCB. There's quite a lot on there, so I'll just give it a little bit of a turn and give it a go again, and I'll just let it sit for a while, I think, as vertical as I can, and hopefully it might seep down inside. But I don't mind putting a lot on. I think that's more than enough now, so I'll just leave that to sit and keep it as vertical as possible and come back in a minute. I'm giving it about 5 minutes now, so I think I'll just try and work it a bit now. Definitely getting better, but whether that's just the shaft being lubricated slightly, I don't know, but I have been putting plenty on it, so I think what I might have to do as well is let it sit upside down and let any of the residual deoxit soak back out. Otherwise it might be leaking forever more out the front of the pot and down the front of the power supply, but it's definitely feeling better now. So I think I've probably got a good chance that I've managed to hit the spot somewhere inside the pot. mean, if worst comes to worst, I can always see what I've got in stock and replace them, but I'd rather leave the original ones on. Like I said, I don't really want to replace too much in this power supply. I want to leave it as original as possible. But yeah, it's definitely feeling a lot better now. So I think I'll leave it at that, and then I'll turn the pot upside down now. A little bit of a wipe down. And there we go. Just let it sit like that for another 5 minutes and let it seep back out again. Okay, that one good enough. I'll do all three and then I'll power it up and then see where we are. Right, and now the middle one. Okay, I'll go way off and do the same with the other two pots and then I'll come back. So I've got it reassembled again just to test the pots. So we're in voltage mode there, and just turning the pot slowly. Just to make sure the needle's nice and uniform as I turn it. Make sure there's no glitches. Definitely feels better underneath my fingers anyway in the pot. Maybe still a little bit scratchy, but basically it's same across the whole range, so it could just be the circlip on the actual front top part of the pot itself there. Otherwise it does seem pretty good. And if I just and I'll turn off the electronic load off camera, 1 amp, to test the current limit. All the way up to 1 amp. It feels, this pot feels better than the coarse voltage adjust one anyway. Does now anyway, so it's all the way right down. And that just feels perfect. Like I said, just a little bit scratchy under the fingers, but the one that feels the best is the fine adjust. It's probably hardly ever been used. It doesn't really have much range, so it's hard to tell with it, but it feels the best under the finger anyway. So I don't think there's a problem with that one at all. So I think we're good to go with the pots just now. Time will tell. So I think the next thing to do is start refurbing the front of it. Okay, next thing we're going to do is tidy up the front. We've got some stickers on there. Hopefully they'll come off, and a little bit of IPA. I should manage to go over the whole thing and clean it up. So let's get on with that. So I'm going to use a small knife here just to get under that without trying to scratch the surface. There we go. That is stuck on pretty well. There we go. And I've got some masking tape over here. And a calibration sticker dated 2005. Well, okay, I'm going to have to soften this up, I think, to get that off. Okay, I've softened it up with a little bit of IPA, and I'm using a plastic tool here. I don't want to use a metal one because I'll just scratch the surface. And I'm just going to try and push the masking tape and glue, etc. Get most of it off, get beneath the surface of the masking tape, and just leave some residue on the front panel that I can then clean up again with some IPA. So this is working pretty well. These are just plastic spludgers that you get in phone kits. I always collect them, and I've got a big box full of them, all different sizes, so never throw them out. You never know when they'll come in handy again. I've got most of it off now. A couple of little bits and pieces to go. I don't want to use acetone or anything like that. I'm afraid it might take off the paint. Worse still, the black screen printed text on top of the paint there. And it will come off eventually, you just need to keep at it. There. That's not too bad, is it? Next thing I'm going to look at is these here. They're rusted, just a bit of surface rust on these little clasps that give the side panel somewhere for the screws to thread into. Now these will just pop off, and I should be able to just lightly rub them down with sandpaper and just to clean them up a bit. I don't like seeing the rust on them, so well, let's clip them off now. And that's all 4 off, so I'll just give them a little rub down with some glass paper. It's just surface rust, it doesn't take much rubbing to clean them up. If you're really keen, you can give them a little light spray with some black spray paint, but I'm not going to bother. I'm just going to clean them up by just rubbing them down slightly. So I'll go way off and do the other ones and come back. Okay, that's all 4 of them done. Some of them are a little bit loose when I'm actually fitting them back onto the power supply. And what you can do if that's the case is they've just opened up and they're not as naturally in the closed position as what they should be. So what you can actually do is just put some pliers there and just give them a light squeeze, not too much because they are pretty brittle. They're hardened metal. Just give them a light squeeze and it should close them up just ever so slightly so that they'll clip into place nice and secure. Okay, next thing I'm going to do is this unit came without feet, so it's actually been sitting on the fuse holders on the bottom there. So I actually went and designed up some replacement feet and I 3D printed these sort of to match the original. Nice recessed stainless steel countersunk screws and a nice little nut and washer on the back there. So I'll weigh and fit these now. The hole in the bottom of the actual power supply is actually quite big, so I actually put like a little ridge on the bottom of the feet so it locates into the hole there nicely. It's just to get them into position properly. So I'll weigh and fit these now and then I'll come back. There we go, that's the 4 feet on, and they protrude down far enough that they more than cover the fuse holders, so that's pretty good. So let's see, there we go, perfect. So now what I'm doing now is I'm looking over the power supply, especially on the outside, to see if there's anything visible that I need to do a little bit of light restoration on. And I'm looking at these screws on the back here that cover the transistors, and they're surface corroded as well. So I think I'll take them out one at a time and give them a light rub and then stick them back in again. Well, they're not coming up too great, especially these crossheads. What can tend to happen is the surface rust in the inside you're not going to get at without maybe a small sand blaster or shot blaster. But that's the subject of another video, hint hint. But so I think I'll have a look at my parts bin and see if I've got any replacement screws actually. Well, I've got some flat heads, so they're almost the right length, or certainly long enough, because the pillars that these are screwed into are quite long and they'll be hollow all the way through, so there shouldn't be a problem. So I'll try one of these for size and see how I get on. Yeah, that looks a lot better. So I'll weigh and change all 4. tight. Yep, that looks a lot better. Right, I think the next thing to do is to take a look at the actual cover for the unit. So let's bring that in. And it's not too bad. It certainly doesn't look like the paint's damaged in any way, really, apart from normal surface sort of stuff. But again, it's the stickers. So I'll just do the same as I did on the front panel. I'll use my plastic spludger and let's get rid of some of these stickers and give the thing a good clean up. Well, that's it assembled. It's about as far as I can take it. Just tighten up the screws on the sides here. There we go. And the other side. There we go. Put a couple of screws on the top there where the handle goes, because actually they go right through and hold the two sort of side ends of the chassis in place. Otherwise this front panel would wobble back and forward. So a screw there and a screw there secures it in place. Now I'm still waiting on the person I got this power supply from is send me the front piece of metal that goes on here that's got Farnell on it, and the power supply is actually missing a couple other parts. It's missing the plastic strips that go right around the edge there, so I don't know if I'm going to be able to pick up any of those, but failing that, maybe I can 3D print something. I mean, I've got enough photographs of what they look like that I could possibly replicate something there and 3D print it, but we'll see how we get on with that. So let's give it a little bit of a power up and see if it's still working. Well, that knob's fitted back on. I am missing caps as well, but I think these are readily available in the likes of RS and Farnell. They're pretty much a standard cap, so I should be able to pick some of them up and get them fitted. Just plain black ones will do. But yeah, so let's power it up, make sure it's still working. Yeah. Perfect. Thanks for watching.